In this lesson, we're going to learn how to solve a system of equations graphically. So what that means is we're going to take our equations, we're going to put them on a graph, and we're going to find their intersection points to find our common solutions. So we've learned now how to graph circles, so you're going to see a circle equation, but we're also going to review how to graph a line and how to graph a parabola from algebra. So this first one, when you look at this, hopefully you're recognizing that this first equation is actually going to be a parabola because it's just one variable squared. So this is going to be a parabola. So for this one, your easiest thing to do is to graph it in your calculator. So let's go ahead and grab our graphing calculators, and since this is already in y=4 form, we can go ahead and we can type that right into the graphing part of the calculator. So go ahead and grab your calculator. So the first thing here is I'm just going to go to the home button. I'm going to go to B for the graph. And then we're going to go ahead and we're going to type in our equation. Remember, if it doesn't show up where you can enter it, just go to menu and then graph entry. And then we're going to just say function. So from here, I'm going to go ahead and I'm going to have x squared minus 8x plus 7. And you can see you have a parabola here. And remember, you can kind of zoom out on the screen. So we can go ahead and we can do that. So zoom out, just so you can kind of see that parabola a little bit better. So I zoomed out too many times. So then from there, what we want to do on our graph is we want to, or on our in our note packet, we want to come up with a table so that we can actually plot these points and reproduce this parabola. Now, if you remember, one thing about a parabola is it has symmetry. So that means when I go to plot it, I should actually have a U shape. It should look symmetric. I don't want only part of it. I want it to actually look like a U shape. So that means when we look at the table, what we're looking for is symmetry, which means you're really looking for repeated values, so repeated y values. So let's go ahead, so hit Control T to get your table. And then what you want to do is you want to look through this table until you start to see some symmetry. So until I start to see some repeated y values. So when I'm looking at this right here is where I'm starting to see some symmetry. So some -8, -8. So that tells me that this 4, -9, that's an important point. That's the vertex. That's the turning point of this parabola. So really, if you find that, then on either side of that vertex, you should graph about 3 points, and that should be enough to get a good representation of what this graph looks like. So that 4, -9 is a very important point. So let's go ahead, and we're going to start with our table. And usually what I do is I put in the middle there where that vertex is. So this is the vertex, this is that turning point, so this is 4, -9. And for some reason, if that doesn't show up in the calculator, all that means is the vertex is happening at a decimal. And in that case, what you can do is you can find the middle point between your x values. So basically it would just be a decimal. It would be like a 4.5 or something like that. So what I need now is to record 3 values below and 3 values above this. So I'm going to record 3, 2, 1. So that means -8, -5, all coming from the table. And then I need 3 values above it, or 3 values to the right of it. So 5, 6, 7. So that means -8, -5, and 0. See how my y values are repeating themselves? That's good, because that means we're going to have a nice looking graph. So now I can go ahead and just plot these on the graph. So I have 1, 0. I have 2, -5. So 1, 2, 3, 4, 5. I have 3, -8. I have 4, -9. And then remember, that's that turning point. So now you should start to see those y values repeating. So that's the same on both sides. Come up to here. And then I'm up at 7. So really, I can kind of graph the rest of the parabola just by using symmetry. But you could also just look at your table. So now I'm going to go ahead and connect these and try to make it as curved-like as possible, but I know it's not going to be perfect. So I have my parabola done. So I'm going to label it with its equation. going to be important to make sure that you're labeling each graph with its equation because you have two equations on here. You want to know what's what. So for this one, this is going to be a line, and the reason why I know it's a line is because it's just an x to the first, and it's just a y. So in that one, what you need to do first is you need to get it into y equals mx plus b form so that we can find the slope and the y-intercept. So I'm going to subtract x from both sides. So I have negative y equals negative x plus 7. Remember, you want the x to be first, so it's in y equals mx plus b. Divide everything by negative 1. So we end up with y equals x minus 7. So from here, you have options. You can throw that in the calculator, get the table, and graph it. You could also just look at your slope is going to be a 1, and your y-intercept's negative 7. So your negative 7 is where you start. So you're going to go 1, 2, 3, 4, 5, 6, 7. And then you're going to count up and over 1 for your slope. And with lines, you want to make sure that you continue that line all the way through your graph. So I'm going to make sure that I'm plotting these points throughout the entire graph. I'm going to take my straight edge and I'm going to make sure that it goes through the entire graph. And I'm going to hopefully use a straight edge, not my marker here. There we go. So now I have my line, and I'm going to go ahead and label that. So that's x minus y equals 7. So now you can easily see the intersection points, my solutions. So I have a solution here and I have a solution here. So since those occur on actual points that I've plotted, not just random intersections between the two graphs, I could actually look at my points. So it's going to be 2, then 1, 2, 3, 4, 5. So 2 comma negative 5, and then this one was 7 comma 0. However, it's still a good idea to check in the calculator, especially if you didn't plot the point. So meaning, let's say it intersected down here where I don't have a point plotted, then you're going to have to do the intersections in the calculator. So let's look at how to do that in the calculator. So what I need to do, I need to hit Control T to get rid of the table. And then I'm going to go back to Menu, and I'm going to go to Graph Entry, and we're going to do Function. And then we're going to go ahead and type in the second equation. So that was x minus 7. So now you see your graph. You can see your intersections again. But in order to find the intersections, if you just go to Menu, anytime you want to do something on the graph where you want to find something from the graph, it's going to be under the Analyze Graph feature. And remember, anytime you're trying to figure out how to do something on the graph, most likely it's under Menu. So that's kind of your options. So you're going to go to Analyze Graph, and then we want to find the intersection. So click on that. And then what's going to happen is it's asking for the lower bound, so that means the left side, and then just drag it over to the right side. And now you see the one intersection point, so that's 7 comma 0. We're going to repeat that process to see the other intersection, the first intersection. So from here to here. And that gives us our other intersection. So we get our two intersection points. You just kind of repeat that process and highlight over the point that you're looking for. So in the calculator, you're going to use the Analyze Graph. So it's number 6, Analyze Graph, and then go to Intersection. So that's how you get to that. Menu first. So Menu, Analyze Graph, and then you hit Intersection. So that's the process. So make sure for this, you're showing your equations, you're labeling, you have arrows on your parabola, your line, you state your solutions. Your solutions need to be stated with parentheses. They are coordinates, x comma y values, so they need to have parentheses. That'll be very important for that. So then the next example, we're actually going to just do it on paper here because it's a little bit more difficult to graph a circle. When I look at this equation here, right away I know that this is a circle. And the reason why I know that is because it has an x squared and a y squared. So if there's no squared terms, it's a line. If there's an x squared but not a y squared, it's a parabola, so just an x squared. And then an x squared and a y squared, it's going to be a circle. And that's a little bit more difficult to graph. It is possible with the Inspires to do that, Um, but it's not as straightforward. So if you want to try it, you can, but what I would recommend doing is just using your knowledge of geometry to graph it. So keeping in mind when we're graphing a circle, there's two things you need to know. You need to know the center, which in this case, there's no numbers by x and y, so it's just 0, 0. And then the radius is just square root the 9, so you get 3. So your starting point's at 0, 0, and you're going to go 3 in all directions. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. If you have a compass, you can go ahead and use that. If you have, well, let me adjust this a little bit. So I'm going to kind of cheat here and use my computerized circle, but if not, you just do the best you can with sketching it to make it look as accurate as possible. So try to use a compass if you have it though, because that'll just make it a little bit nicer. So there's my graph of my circle. Then I move on to the next equation, which I know is a line, because again, it doesn't have any squared terms. So y plus x equals 3. I need to get y by itself. So I have y equals negative x plus 3. My slope is going to be negative 1. My y-intercept's 3. So I'm going to start up at 3, and I'm going down 1, right 1, down 1, right 1, and continuing that process. And you can backtrack. And basically, I've already found my intersection points. I see them right here. So that means I don't really have to draw every single point, but you should be using a straight edge and making sure that your circle or your line is going through your entire graph here. So I'm just going to extend that out. So there's my line, which is y equals negative x plus 3. And then my solutions, like I said, we can see those already. Remember, they're points. They have to be points that you've actually drawn. You're not just estimating. If there aren't points that you've drawn, then remember that's where you're going to have to use your calculator. So for circles, they should work out nice. So we have 0, 3 as a solution and 3, 0. And again, notice my work. I have my solutions stated with parentheses around them, and I have my equations labeled and graphed. I have arrows on my line, my circles connected, and that is a perfect picture right there. So that's really what you need to be able to do. So from here, go ahead and do the check your understanding problems.